Hi students, welcome to chemistry online classes. In the last class I discussed about the acidic nature of carboxylic acid, that is called OH bond breaking reaction. So we know this is RC double bond OH react with the H2O, then this bond will be break down. Then we will get here RC double bond O minus plus this H and this H2O, this is combined to form H3O plus. The acidic nature of carboxylic acid is decided based on the formed anion should be stable. If it is more stable, this acid is more acidic nature. Next, so that is last class I discussed about this one only. Now RC double bond O minus, it undergo resonance. This negatively charged comes to here bond form, this pi bond shifted towards the oxygen. Then it converted into RCO minus and C double bond O. These are equivalent resonance structures. What do you call this? Equivalent RS means resonance structure. So we know that negative charge on the more electronegative atom, positive charge on the less electronegative atom, that resonance structures are more stable. That you know in the first year resonance in chemical bonding chapter also is there, in organic chemistry also is there. Now this resonance structure is more stabilized, and this resonance structure depends on this R group also. If this group is donor group or this group is withdrawing group. Electron withdrawing groups are the electron donor groups are the you studied in the inductive effect and mesomerical resonance effect. So I will give you some donor groups and some withdrawing group. This is CH3 electron donor group and C2H2 all alkyl groups. Otherwise I will write here all alkyl groups are which one? Electron donor groups. Next. This is called electron donor group, EDG, electron donor group. Not only this one, some other also, some example I am giving here. Next, electron withdrawing group. Electron withdrawing group is CF3 on carbon. If H is there, there is CH3. Instead of this hydrogen, we have which one? Fluorine. Fluorine is electron withdrawing, electronegative. Electronegative, it pulls electron towards itself. Like this. Next, bond CCl3. Next, CHCl2. Next, NO2. Next, cyanide. Like this, so many other. I am giving a few examples. If you don't know, once again refer your first year. Inductive effect and resonance effect. These are some electron withdrawing, these are electron donor group. And here, if you want, this is also electron donor group. This is also electron donor group. Okay. This is also electron donor group. This is methoxy. Or we can write like this also OR. R may be methyl, ethyl, propyl, whatever the group. These are electron donor group. This is electron withdrawing groups. Now, carefully observe. R group is electron donating aroma towards this carbon. This is donate towards this one, C double bond O minus. For this we can write the one resonance hybrid structure. Resonance hybrid structure is O. This is that. Its meaning what is that? This negative charge on the oxygen may be on this oxygen or this oxygen. It is instantaneously changes. That's why it is represented like this. This is called resonance hybrid structure. Generally, these are called resonance structure. This is resonance hybrid structure. Resonance hybrid structure is more stable than the remaining resonance structure. That is very important to decide some chemical properties. Now R group. This group may be anyone. Now I just indicate. Otherwise you can write here donor group in EDG. EDG means electron donor group. Electron donor group is present. Then electron density at this carbon then increase or decrease? Increase. Already here electron density is there. So electron density increase means somewhat it is less stable. So electron donor would destabilize this carboxylate ion group because negative charge increases, stability what decreases. Therefore, electron donor group decreases. Electron donor group decreases stability of RC double bond O minus. Otherwise, we can this dash anyone do this. This quad stability will be decreases. Next one, electron withdrawing group. Electron withdrawing group, what is the meaning? It takes the electron from this C double bond O minus group. That's the arrow mark I given towards the EWG, taking electron from this COO minus. Then when here electron density decreases, so what stability increases. So electron withdrawing group increases stability of C double bond O minus. Clear? Then already we know that this anion, if it is more stable, then this acid is more acidic. Then which will increase the acidic nature, donor group increase the acidic nature, or electron withdrawing groups increase the acidic nature, electron withdrawing group increase the acidic nature, because electron withdrawing group increase the stability of this group. So this type of groups are present, then acidic nature more. If this type of groups are present, the acidic nature is less. Therefore, I will write here one statement: plus I or plus R group decreases acidity or acidic nature of carboxylic acid. Why it decreases the acidic nature of carboxylic acid? It decreases stability of this anion. Clear? If it is more stable, more acidic. But this electron donor decreases stability, then automatically acidic nature also decreases. R group means what is that? Not this alkyl group. Resonance. Generally, resonance denoted with the R. R mesomeric group. Sometimes some certain there is also plus M. Plus M means mesomeric. Positive mesomeric or positive resonance. Plus I means what is that? Inductive effect. Similarly, here minus IE, negative inductive effect, or minus M, this may be different, or minus R, negative resonance group in negative resonance group increases acidic nature of carboxylic acid. So you have to remember this statement. This is only for your understanding all this work. Only two lines are very important to decide the acidic nature of carboxylic acid. Now I will write here one order based on these two statements. Now F3C C double bond OH. We know that this is a CH3 C double bond OH. What is this? Acetic acid. Instead of here 3 hydrogen, what we have? 3 fluorine. So like this group is present here. CF3 is electron withdrawing group. Electron withdrawing group increases. It means minus I group increases. Acidic nature what happened? Increases the acidic nature. So here it is more acidic. Now if you take the Cl3 C double bond OH, fluorine more electronegative or chlorine more electronegative? Fluorine. Fluorine more electron withdraw, more stabilize this carbon ion. Therefore, it is more acidic, this is less acidic. Similarly, Cl2CH. How many hydrogen here? 3. Instead of 3, here 2 chlorines are there, 1 hydrogen is there. So here 3 chlorine means more electron withdraw, 2 chlorine means less withdraw. Less withdraw means less stable, less stable means less acidic nature. Therefore, C double bond to OH. Next, NO2 group, CH2. Here how many are there? 3. 1 hydrogen replace the NO2 and remaining as it is COOH. Next, cyanide also is there somewhere there. Then NC we have to write because carbon is bonded here, not nitrogen. This is called cyanide, not isocyanide. Okay. This is less acidic. Similarly, next, it means after this continuation part I have here. 1F CH2COOH. Next is Cl CH2COOH. Next Br CH2COOH. Next formic acid. Next Cl CH2CH2COOH. I will explain, don't worry what is the exact part. Next benzoic acid. Next this is given order in your textbook. I remember it's easy for me. For you, this order is not required to remember for PU purpose. That is not required because in PU purpose they will give you the question. Two acid they will give in that which is stronger, which is weaker. Okay. So in text question what is there? Or solved question is there? That one only will give you the PUC board. But like this total lengthy answer will not ask in the examination for PUC. Competitive exam purpose only they may ask the 4 option in that give the order which is acidic, increasing order, decreasing order like this question will ask. This is we know 3 fluorines are there, more electron withdrawal, more stabilized harmony, more stable, that's why more acidic. Here chlorine is less electronegative than the fluorine, less acidic. Here 3 chlorine, here 2 chlorine is there, here nitro group. So this order you learn in the first year, which is more electron withdrawal, which is less electron withdrawal. So all this I can discuss in time taking course, I am not discussing here. So here only you consider which is more electron withdrawal, this more electron withdrawal, this group, this less, this less, this less, less. Same order you have to consider. Now here fluorine is there. Here chlorine. We know order electronegativity. Fluorine, chlorine, bromine, iodine. Top to bottom electronegativity what happened? Decreases in the group. Left to right in the period electronegativity increases. So this group fluorine, chlorine, bromine is there. Here formic acid. Formic acid is more acidic than this benzoic acid also, acetic acid also. Why? Then you may ask the question here for this important reason. H C double bond to OH. After last of this H, this will be get which one? O minus, and if it is water is there here, then it form here H3O plus. Now this anion is like this one, but here what is there? R. Here nothing close is there. H is neither much donor, not much electron withdrawing. But these are having some donor and withdrawing H also. Which one? This benzene group or this methyl group. Therefore, these are less acidic. Here is more acidic region. No donor group, no electron withdrawing group compared with this benzoic acid and acetic acid. Here methyl group is which one? Donor group. Donor group what happened here? Decreases the acidic nature. Here what is the phenyl group? Phenyl group is generally electron withdrawing group, and sometimes it is donate also. That also we will discuss based on this resonance. So this is very important because student will confuse here because one statement will be there. Aromatic carboxylic acids are more acidic than the aliphatic. Got the point? This which one? Benzene aromatic. Formic acid is one aliphatic. Then that time that statement if you apply, then it is wrong. Got the point? Which one is more acidic? Aromatic is more acidic than the aliphatic. This aliphatic, this is aromatic, but also this is more acidic nature. This is less acidic nature. Why? I will now reason. Consider this is CH2 double bond CH, C double bond OH. This is vinyl group. So this is vinyl. This is phenyl. I will explain with this. You can understand the same as like this. Okay. Now after loss of H plus this H plus, then what we get here? CH2 double bonds, CH C double bond O minus plus H plus if water is a H2O plus. Okay. This anion, if you observe, then what is the resonance structure? Sorry, not this one, equilibrium. This is resonance structure. Now, this pi bond shifted to here, this will be shifted to here. Then we will get here positive charge, the single bond, CH double bond, O minus, O minus. Clear this is? Now, this group electron donated to this one or withdrawn? Arrow mark observe, moving which side? COO side or towards the CH2 side? COO side. It means moving towards it donated or withdrawn? Donated. Donated meaning what is there? Donor group, well, positive. Decreases the acidic nature of carboxylic acid. But here exception. So you only told here donor group decreases the acidic nature, but it is donor group like this through conjugation, but due to this double bond carbon. Already I told you that single bond sp3 hybridization, double bond sp2, triple bond sp. Electronegativity order En increases. Electronegativity what happens? Increases. S character increases, electronegativity character also increases. Therefore, this carbon is which type of carbon? sp2 hybrid carbon. sp2 hybrid carbon compared with the sp3, electronegativity what is it? More. More electronegativity means electron withdraws. So here donor also is there and withdrawing also is there. Somewhat mutual connection, but withdrawing only predominant character. Therefore, it is acidic. Similarly here, you can consider the benzene. After loss of this H plus, then we will get C double bond to O minus. H plus I am not writing here. Then this Y bond shifted to here, this will shift to here, similar to this. Again, it is what is that? Phenyl group donating electron to CO. But also, aromatic is more acidic. Normally, I told you that. Reason which carbon is carbon? sp2 carbon. sp2 carbon is electron withdrawing. That is a condition. Therefore, aromatic are more acidic than the aliphatic. But in this case, it is less. Compared with this formic acid, benzoic acid is less. Reason here, donor also is a withdrawing acid. Such type of group not present here, and that is two equivalent resonance states we will get like this. Therefore, that is more stable and more acidic formic acid compared with the remaining this benzoic acid, phenyl acetic acid, acetic acid, and propanoic acid. This is the condition. Okay. Now we will consider some aromatic carboxylic acid. This is COOH, OCH3. This is benzoic acid. This is para-nitrobenzoic acid. One more thing is, you have to concentrate how to write the benzene. All bonds are equivalent, you have to write like this. Because I observe that many students will write like this. Like this. So it is not, looks good also, and it is not the benzene. Because you studied in the first year, in benzene, this carbon-carbon bond is 1.39 something is the angstrom. So all bonds are equivalent. If you write like this, these are length, this is smaller. So don't write, and some students will write like this also. See, it looks like benzene, but there is no connectivity there here. This is not the benzene. Due to this, sometimes you may lose some marks also. You may feel in exam I wrote correct, but they will give 0 marks also. They will show this is not a benzene. So each and everything consideration will be there. Now this is a benzene. But sometimes we will also write on board like this, but you have to consider because I am telling already what is the mistake we will do. Okay. Now this is donor group already shown here. Methoxy donor group. Here nothing is there. Here one electron withdrawing to NO2 group is present. So NO2 group is electron withdrawing. Electron withdrawing groups minus IR, minus M or minus R groups are increases the acidic nature of carboxylic acid. So this is more acidic. This is donor group, less acidic. Here nothing is there, any group. Then nothing is there which is more acidic than the NO2R, more acidic than the this methoxy group or less acidic. We have to decide. Anyway, electron withdrawing group is there. See clearly, arrow mark I am showing downward towards the NO2 group. It is electron withdrawn. NO2 group taken the electron from the benzene ring. Okay. Here no group. Here it is donated to the COOH. Donor group decreases the acidic nature. Anyway, it is least. Here no group is there. That's what it is in between. So already I know that's why I wrote in between this is. But in examination they may not give middle also. They will give this is first, this is the second, this is the third also they may give. You have to understand which is the more acidic, which is the less acidic. Donor group decreases the acidic nature. Electron withdrawing group increases the acidic nature. This is the order. So I will do the homework for you. You have to decide. This is the benzene. How many are there? 4. This is COOH, benzoic acid. COOH, benzoic acid. COOH, benzoic acid. COOH, benzoic acid. Now we will take one NO2 electron withdrawing at different position. This is without any groups. I will write this is the ortho position NO2, meta position NO2, para position NO2. This is a homework for you. Same groups are present. When same groups are present, but at different position, one is ortho position, one is meta position, one is para position. Then how to decide? This type of explanation given in the phenol acidic nature. Once you revise that, then you will understand. But one extra concept will be there here. What is the extra concept here? Ortho effect. O effect means what is it? Ortho effect. Otherwise you can write completely ortho effect. Okay? Ortho effect means what is it? Irrespective of any group. Irrespective means whatever group is present, electron withdrawing group present, electron donor group present. Any group present at the ortho position that is more acidic than the remaining meta and para position carboxylic acid. So now you know that. Tell which is the more acidic nature now. This one only. Otherwise you give number 1, 2, 3, 4. If you write the acidic nature, then which is the more acidic? Second one only the more acidic. Reason due to ortho effect. This concept applicable for this benzoic acid derivative substituted this benzoic acid, not for phenol. Ortho effect is not applicable for phenols. That is also conditional. Okay? Only applicable for this and next if any further chapter that I will discuss. But in phenol, ortho effect not applicable. So now it is a more acidic. This is very clear. Then apply now. Here NO2 group is there, here also NO2 group is there. Then which is more acidic nature now? To decide that we have to write the resonance structure. Because after loss of this H, that anion should be more stable. Already I explained that. So which gives the more stable anion, that is the niche. Clear? Now always we can't write the resonance structures because in exam how much time will be there? Very less. So if you write the resonance structure, that only takes nearly 2 minutes. Generally one question 1 minute will be there for completing exam. So now decide this is which group electron withdrawing. At meta position minus R group will be absent. Minus R minus M group will be absent. This is not absent. Through meta operation, that resonance effect is not applicable. Which effect is applicable? Minus I effect is applicable. Because it is distance dependent. You may have studied in the first year, inductive effect applicable up to 3 carbon. After 3 carbon it disappears. Studied or not? Just want to revise this. So here, how many effect is present? 1. Here 1, 2, 3, 4th position. At 4th position, minus I effect is disappeared. Because applicable it is up to 3 carbon. But minus R is applicable. Through para position, ortho position, resonance effect is applicable. But you know that resonance or mesomeric effect is predominant than the inductive effect. You studied the first. Then which is more acidic now? Para position is more acidic than the metal. Therefore, now 4th, next, 3rd, here no group is there. This is last. This is R. So always we can't write the resonance section. How to decide? You should know the inductive effect. You should know the mesomeric effect. Sometimes hyperconjugation also. Here hyperconjugation effect not there. That's why not explained. Sometimes hyperconjugation also. So each and every consideration at a time, if you involve in this concept, then only you will answer. Otherwise, this part is very difficult. So I given the hint how to decide. Molecule given, what are the effects are applicable for one molecule. So sometimes 2 effects are applicable, sometimes 3 effects are applicable. More effects are applicable, more acidic nature. That should be minus I. Minus I effects are minus R effects are minus hyperconjugation. So more minus I, more acidic. More plus, less acid. That is the answer. So this is about the acidic nature. Like so many possible. Once again, I will give the homework for you based on this group also. Where here OCH3 group is there. This OCH3 group, remove NO2, put OCH3, and this is the acidic nature. One more example also possible. NH2 group is there. NH2 group. So this NH2 group, remove here NO2, put NH2. Remove the NO2 group and put here OH. So like this, how many possible? So many examples are possible. If you don't know, once again revise your inductive effect and resonance effect. Based on that, we will decide this. Okay. Next one is this is called OH bond breaking reaction part completed. Next part is this one, CO bond breaking reaction. CO bond breaking reaction. This is second type. First type what is the OH bond breaking. Second type is the CO bond breaking reaction. In CO bond breaking reaction is first one, anhydride formation. Anhydride formation. What is the anhydride? RC double bond O, C double bond O, R. This is anhydride. Carefully observe. H2SO4 or P2O5. These are dehydrating agent. Dehydrating agent means what is that? They remove the water molecule. Dehydration, what do you know, in summer generally we lost water and it is thirsty feeling. So here also dehydrating agent, water removal. One example I am writing here, CH3, C double bond OH. How many moles of acetic acid is there? 2 moles. See, here which bond is breaking? CO bond breaking. CO bond. But here, OH bond only breaking. Any one of the molecule lost here, CO bond. And keep in mind, generally acids are represented with H plus and heat. Otherwise, what we have to do? P2O5 and heat. Anyone use, not both at a time. Anyone. This part you can use, not this one. Acetic acid treated with the H2SO4, generally concentrated. On heating, we will get